For our project, we are working with Children's Community Pediatrics, the largest pediatric provider in Western Pennsylvania, with 38 locations. A large part of their day-to-day function is vaccinating children. Vaccines must be kept at certain temperatures to remain potent and effective. A vaccine cold chain failure is when vaccines are exposed to temperatures outside of its limits, whether it's too warm or too cold. Because of this, vaccines are kept in highly regulated refrigerators and freezers. In the past year, CCP has experienced at least 6 vaccine cold chain failures. Consequently, CCP has incurred costs as a result of wasted vaccines and extra administration costs to revaccinate their patients. This also reduced the quality of their service as patients lose trust in them as providers and in the vaccines themselves. The group Vaccines for Children and the CDC have outlined regulations on how to store and handle vaccines to avoid cold chain failures. A large part of this is how to monitor the temperatures of the refrigerators and freezers. Here you can see some images of the CCP vaccine storage system. Twice a day, nurses record the temperature of the units on paper logs from the VFC. Our approach to solving the problem was to complete a root cause analysis to investigate the source of the vaccine cold chain failures. First, we completed a 5-why analysis where we visited CCP locations to explore each individual temperature excursion by digging deeper down to the true source of the problem. Next, we created a fishbone diagram to investigate the possible causes due to measurement, materials, method, environment, manpower, and machine. Finally, we completed a failure modes and effects analysis to investigate all possible modes of failure in the current system. We rated them and then determined the potential causes of the failure modes and the process controls. Overall, we determined the root causes of the failures were human error, lack of a standard procedure, and delayed identification of failures. For our solution, we decided to create an Excel document to electronically log temperatures and detect temperature excursions. Offices can access this Excel document on tablets. We also decided to create a single standard procedure for all CCP locations.
Right now I'm going to walk you through how a user would enter the temperatures that are displayed on a thermometer on a given refrigerator. They would select one of these 5 buttons that corresponds to the appropriate refrigerator. This will take them to the temperature log screen where they click in the name cell, press the drop-down button that displays the drop-down list where they select their name. The timestamp and machine ID are already filled in. Then they merely enter the min, max, and current temperatures. For this example, I entered a value for a minimum that is below the lower specification limit. This is to demonstrate what will happen when an excursion has occurred. Whenever they press the Export Data button, this will take them to the excursion screen where it's big and red and easily notifies the user that an excursion has occurred. From here, they follow the sequence of prompts and message boxes that guides them through how to take corrective action. There is also the chance for them to correct any values that were mistyped. If everything was properly entered, they follow with the yes protocol, follow the SOP, and take corrective action. This will save the data and take them back to the home screen as seen here.
We implemented our model at the CCP Brentwood location for 2 weeks, which allowed us to get feedback on the new system and help fix any errors. Overall, our solution helped to improve quality and cost of vaccine cold chain failures. We distributed surveys to the Brentwood staff before and after reviewing our SOP to determine if their knowledge on vaccine storage and handling was improved. We saw a 15% increase in the survey scores. We also updated the FMEA. As you can see, our updated FMEA shows drastic improvement scores, some up to 300. Lastly, we created some short-term and long-term recommendations for how CCP should implement our solution at all of their locations. For example, we will be teaching the IT team about the Excel document VBA coding and how they should customize the solution for each office. To justify our solution, we did an approximate cost-benefit analysis on the cost of a failure. When a failure occurs, the cost of discarding all affected vaccines can be up to $6,735. If the failure isn't recognized right away, it can cost up to $2,000 per day that it goes unnoticed. Finally, we want to say thank you to everyone who helped us complete this project, and thank you for listening.